This is a fractal plot. It's called the Mandelbrot set. You may have seen it before. And a fractal plot basically is a system where no matter how far you zoom in, you get the same repeating pattern. Okay. So here, this is, like I said, a Mandelbrot set. If I zoom into this point, okay, that looks the same as this. Okay, and if I zoom into that point, that looks the same as this, and so on. So no matter how far I zoom into this system, okay, I get the same picture. Okay, so that's what defines the fractal plots. Basically, I've put a definition up here. Okay, means that the spatial or temporal resolution is increased again and again, e.g. smaller and smaller length scales, more and more detail appears. Okay, so no matter how far, essentially you don't know how far you zoomed in once you, like I said, this is the picture of the whole thing. But like I said, the moment you start zooming in, this is this, and so on. And, each of these will be the same sort of thing. And that's, like I said, that's called a Mandelbrot set. That's a particular example. As you zoom in on the image, at finer and finer scales, the same pattern reappears, so that it's virtually impossible to know at which level you are looking. Now, a self-similar surface, okay, so this is a term, self-similar surface, means that it's statistically similar at all length scales, okay, so that Mandelbrot set is an example of that, okay. Now, a self-affine surface is similar at 2 dimensions, okay, so like the edge or something of something would be 2 dimensions, and that's at magnification m, but the third dimension has a different magnification, m to the power of h, where h is known as the Hurst index. And so you've got, like I said, a 3-dimensional surface. The edges of that surface, okay, if you zoom in at m, will be the same as if you were looking at it originally. So, like I said, that's like a Mandelbrot set, 2 dimensions. But there'll be a third dimension, okay, and to get the repeating pattern, you have to zoom by m to the power of h, where h is known as this Hurst index. It's just a bit of information. But there's an example, okay. Self-affine fractal surfaces appear similar when subjected to anisotropic distillation, which is what this is about. You're looking at different magnification things of the different dimensions. An example of a self-affine fractal surface occurs when a brittle material is fractured, okay, or road surfaces is another. No, road surfaces is one. I've not mentioned it there, and the coastlines are also a fractal surface. The closer and closer you look at a coastline, the more you'll see a repeating pattern.